For the given network, determine all currents. We have three resistors. So we're going to have three currents which will go through these three resistors, plus we are going to have total current. In other words, we have to find four currents. Okay, the easiest way to find the currents which are going through these three resistors is simply Ohm's law. So you have to keep in mind that in parallel circuit, the voltage across each resistor is equal to the voltage source. Okay, so we can say that V1, which is my voltage source, is equal to voltage across resistor R1. This is also equal to the voltage across resistor R2, and this is also equal to the voltage across resistor R3, and this is equal 20 volts. Okay, so if I want to find current which goes through resistor R1, I simply write that I R1 is equal VR1 over R1, okay, and this is equal 20 volts over R1, which is equal 30 kilo ohms. Okay, so we have 20 divided by 30 exponent 3. Okay, this is equal 667 microamps. Okay, next we're supposed to find the current IR2. IR2 is equal VR2 over R2. VR2 is equal 20 volts over R2, which is equal 60 kilo ohms. So we have 20 volts over 60 kilo ohms. Again, we are going to practice the calculator. So we have 20 divided by 60 exponent 3. This is equal 333.33 microamps. Okay, so this is the current which will flow through the resistor R2. Next, I'm supposed to find the current which will go through resistor R3. So if I R3 is equal VR3 over R3. VR3 is equal what? 20 volts over 90 kilo ohms. Okay, so we have 20 divided by 90 exponent 3. This is equal 222.22 microamps. Okay, so this is the current which will flow through the resistor R3. Now we can find I total. I total I'm going to find by using KCL, Kirchhoff current law. So I total is equal I R1 plus I R2 plus I R3. Let me remind you that my total current is going to flow over here. This my I total is going to flow also over here. Okay, and this is going to be my IR1, this is going to be my IR2, and this one is my IR3. So IR1 is equal 667 microamps plus 333.33 microamps plus 222.22 microamps. So this is equal 667 exponent 6 negative plus 333.33 exponent 6 negative plus 222.22 exponent 6 negative. This is equal 1.22 milliamps. Okay, so we found the currents in each branch and we found I total. In order to verify if our answers are correct, we can always find the total resistance. Okay, so we have R total is equal 1 over, because I have more than 2 resistors, 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is equal, let me just be clear, okay? So we have 1 over R1, which is equal 30k, plus 1 over 60k, plus 1 over 90k. This is equal, again I'm going to use the calculator, 1 divided by open parenthesis, 1 divided by open parenthesis, 1 divided by 30 exponent 3, plus 1 divided by 60 exponent 3, plus 1 divided by 90 exponent 3. Close parenthesis equals, this is 16.36 kiloohms. Okay, let me just remind you that total resistance in parallel circuit must be always less than the lowest resistance in the circuit. Let me remind you also that these 3 resistors you can simply replace by one resistance. Okay, you can redraw the circuit and your circuit is going to look like this. Okay, so this is V1, which is 20 volts, and R total is equal 16.36 kiloohms. Okay, so you can replace these 3 resistors by one resistor like this, and the circuit is going to do exactly the same job, we can say. Okay, so now let's continue. So next I'm going to find total current. Total current is equal V1, which is my voltage source, over R total. V1 is equal 20 volts over 16.36 kiloohms. This is equal 20 divided by 16.36 exponent 3. This is equal 1.22 milliamps. Please notice that we got total current by using 2 different ways, okay, and we got the same result. So it means that our solutions are correct. Okay, and these are simply the answers to our problem.